Welcome back to the Foundation in C# course. We are currently in Module 3, and this lesson, we're going to be covering advanced exceptions. Now, don't worry, we're not going to go so deep into exceptions that it's really confusing. We're just going to cover some more, I call them advanced scenarios that you might not hit every day, but that you should be prepared for so that you feel comfortable working with the exceptions. Okay, so let's go ahead and open up Visual Studio and get started. Let's go File, New Project, Windows Desktop Console Application.NET Framework. We'll call this Console UI, and this is Advanced Exceptions Demo. And the first thing we do is add a console.readline at the end. Now notice we've done this a number of times, this initial setup, and I don't do it off camera. I do it on camera right now because of the fact that you need to get in that habit of doing the same thing the same way every time. That way you don't forget the little things. And that way you're very comfortable creating projects, especially console applications. So don't try and shortcut this process or create a template or something like that where you start off right here every time instead of starting off with a file new project, because then you're robbing yourself of those foundational things that if you do them will give you that muscle memory, that ability to just kind of do it almost in your sleep, but not really. To be that comfortable with it that you are confident in what you're doing. That comes with practice. So don't rob yourself of that by somehow shortcutting the process. All right, so we've got this console application, and we're going to set it up to create some exceptions. Now, this will be a little bit contrived, and the reason why is because I don't want to write complicated code that you'd have to understand in order to understand why it's not working. So instead, we're going to kind of create a sample. It's a demo, but it will give us all the pieces necessary to understand some more advanced scenarios in exceptions. So let's start off by creating a method, a private method, private static void. And remember, void means it returns nothing. And we're going to say this is our simple method. And in here, we are going to throw new exception. Now, if I type out exception, notice that my list, it highlights exception, but there's a number of other items in this list, and they all have one thing in common. Somewhere in the name, they have exception. These are the different types of exceptions that come out of the box with .NET. So, some of them are very easy to understand. Argument exception, argument null exception. Well, an argument null exception would probably indicate that the argument or the value they passed in was null. Argument out of range exception. It's kind of similar to what we looked at earlier with exceptions where we had that index out of range. Well, it's argument out of range. So maybe you said, what is your age? And a person put -5. Well, -5 is not a valid age. Therefore, you might throw back an argument out of range exception. So what we're going to do is we're going to pick one. And it doesn't really matter which one we pick. We can pick any. We can even pick the standard exception. But let's grab one here that says invalid operation exception. That sounds about right. So for whatever reason, if you call this method, it's an invalid operation. You shouldn't be calling this method. Now, I could just open and close it, and that's it. But I miss an opportunity if I do that. Inside here, I have the option. We have 3 different versions of this method to call. This is called method overloading. And what it means is you have 3 different options in this case of different parameters to send to the method. We're going to cover this more in our object-oriented programming sections. However, for now, just know you have 3 different options here. One of them, number 2, so the first one, it sends no information. Just says, hey, throw this exception. Number 2 says, pass in a message. The message that describes the error. That's really helpful. And then number 3 is pass in the message and an inner exception. We're going to do number 2 for this one. You should not be calling the simple method. All right, that's our message. This, remember the ex.message? That's what that is right there. Now, if we were to call this method, simple method, because it has a throw new invalid operation exception, it's going to cause an exception to occur. If we run this, it's going to stop right here. It's going to highlight it and say there's an exception, an unhandled exception. And the message is you should not be calling the simple method. That sounds familiar because that's the message that we specify. If we look here under message, we'll see that it says you should not be calling the simple method. So that's our message that we set. It does tell you in this section right here, it tells you where the message occurred, the stack trace. In fact, if we pop this open, notice it says that it occurred on line 19 inside a simple method, but that its parent was the main method, line 13. So line 13 calls simple method, and simple method on line 19 actually had a problem. So it works just like an exception you saw before. It's just that in this case, we created the exception. So it's not something happened outside of our control. This time we say, you know what? We're going to cause an exception. So the very first question you should probably ask is, why would you ever cause an exception? Exceptions are bad things, right? Well, not really. Exceptions are a very valuable part of our application. What they do is they tell the rest of our application that there's a problem. There's something that was unexpected that happened. In this case, an invalid operation happened, or an argument out of range happened, or something else. We could change whatever exception it was. So why would you throw an exception? Well, the most common reason to throw an exception is because you are not the top dog. Now, in this example, we are the top dog. What I mean by that is we are on the user interface layer, the UI layer. So we can talk directly to the user. We can say, hey, there's a problem. So I probably wouldn't throw it right in the UI layer. I would probably just tell the user, hey, you shouldn't be doing this, and then exit out of the method. But if I'm in a class library, which we'll cover in the future, but essentially a library doesn't have access to the user interface directly, in that case, I would throw an exception because then, remember, exceptions bubble up. And so they keep going up this call stack until they get to the very top, and if they're not handled, at the very top even, then it becomes an unhandled exception. But until then, it keeps going up the chain. So if this were somewhere else that did not have access to the user interface, then we would throw an exception. That way we allow the higher-ups to handle it. In this case, what I should be doing, pretending this is a library that has no access to the user interface, is I would wrap this, remember, snippet, surround with try, and then I would catch the exception. And not rethrow, I would just catch it and do something about it. In this case, I'll print it out, and I might even exit the application or something like that. But in this case, I'm going to leave it alone just at that. So I'll just print a message out and that's it. So now if we run this, it runs just fine. It says you should not be calling the simple method. So it printed that message out for us. Okay, so I had access to the user interface, so I did something about it. Okay, so that's a very simple example, but what it does, it shows us that we can create our own exceptions. Now, if you notice, throw new invalid operation exception, this actually creates a new, what's called an instance. And we're going to cover that again in object-oriented programming, but essentially it creates a new copy of the invalid operation exception. When I catch, I say catch exception. That's a little different. It's not an invalid operation exception that I'm catching. It's just an exception. And the reason why is because exceptions work on a hierarchy, meaning that this is a more specific type of exception, whereas this, just exception, is the general type. It's like saying exception is car and the invalid operation exception is a Toyota. So this is a more specific type of this. Now, we do have the option of catching different types of exceptions and handling them differently. So the next thing we can do is actually catch more than one type of exception. Okay, so there I've done is I've actually added a second catch block. So I have two catch blocks now. One for invalid operation exception, one for a general exception. And the way this works is the first one that matches gets picked. So if the exception is an invalid operation exception, it comes in here and runs this code. If it's an exception, but not an invalid operation exception, it comes down here, gets caught in this one, the most general one, and it runs this code instead. Now, if you mixed up the order here and put this catch block on top, it would catch all the exceptions because it's the most general. So don't do that. Always be the most specific to the most general. So you can see I did something different in this one. And maybe we can do another console write line that is ex dot, I should do message. So I'm printing out a message beforehand and then the actual message. If we run this, we'll see that we're calling both. We're having these two lines run. You should not be calling these methods. You should not be calling the simple method. These two lines right here, and not this line down here because we caught in here. And so therefore we skipped this exception. Okay, so now what we can do is create another method with a different type of exception. And let's call this different method. And I'm going to throw an exception that you're going to see a lot, actually. Throw new not implemented exception. This is kind of a special one because you'll see this if you ever use auto-generated code. And what I mean by that is Microsoft or Visual Studio allows you to generate some code automatically. So for example, if I didn't already have this, let's just cut this out for a minute. And let's come up here and say different method. Now notice different method does not exist, which is why I get the red squigglies. But if I put my cursor over here, this little light bulb right here with the red in it, it comes up. Or if I hit Control Dot while my cursor's on this line anywhere, Control Dot, either one brings up this menu. And it gives you options for how to resolve this problem. In this case, it says the name different method does not exist in the current context. Do you want to generate method program dot different method? Notice it says right here, private static void different method, throw new not implemented exception. If I click on that, notice the red squigglies go away because it created a method for me called different method. It looks exactly like mine. That's not because it figured out what I wanted to do. That's because I was creating something that it would normally create. So that's a quick way to generate some code. But why does Microsoft, by default, put this line of code inside my method? Well, the reason why is because you were up here doing work and you're saying, you know what, create this method. Maybe I came down and said, create another method. Maybe I'm just on a roll and I say complex method. And I come back over here and say Control Dot, hit Enter, and it goes away. And now I'm good to do the next thing. Well, what if I forget to do something with these methods? Guess what happens? If I run my application right now, it says the method or operation is not implemented. What is that saying? And why is there only one line of text here? Because the very first method had a problem. It went to that method and got down here and said, oops, throw a new not implemented exception. So it throws an exception, which comes down here to the catch block and says, is it an invalid operation exception? No. Is it an exception? Well, sure it is. So write out that message. So that's what happened. But why did Microsoft do that? Why did they throw an exception? Well, what happens if we don't have this line of code? If I run my application, it runs like it used to. Awesome. But what am I not doing? I'm not doing anything in different method. I'm not doing anything in complex method. Do you think I intended to do nothing in those methods? No, I intended to do something. I just forgot to go down there and actually write some code. So Microsoft says, yeah, we know how it is. You forget to do things. And if you forget to do something, you might even get to production where you think something's working and it's not. Maybe this method, what it does is it takes out bad data. And normally it just ignores data and it says, yep, it's good, it's good, it's good. But when it gets the bad data, it deletes it. Well, if it's not doing anything, what is it not doing? It's not deleting the bad data. But the good data works just like it used to. So if you're not seeing bad data come through, you wouldn't even know it's a problem. And so you think your application is working great. You push it to production, and all of a sudden your database has bad data in it. So Microsoft says, yep, we understand the problem. We've got a solution. If you do not put any code in your method, we're going to throw a new not implemented exception and say, yeah, you did not implement this. In other words, you didn't actually put any code here. So I'm going to blow up because something unexpected happened. Make sense? So if you see this, don't just go, oh, delete that code. I personally will write code right above it. And then not until I'm done writing code will I delete this line. So if I'm halfway through completing the method, it will still throw a new not implemented exception. That way, if I forget, if I go to lunch and I come back and I was only halfway through that method and I forgot that I just check my code in and go, well, that'd be a problem but it's not now because it still throws an exception. So we're going to leave the different method. We're going to leave the throw new not implemented exception here. And we're going to catch it. We're going to catch not implemented exception. And you know what? We're not even going to put a variable there. And we're going to say, you forgot to finish your code. Let's put some exclamation points just to emphasize the fact that, need to do something. So why didn't I put a variable here? Well, because I'm not going to actually do anything with that variable. I don't need to know that it's a not implement exception. I don't need to know that I didn't implement some code. I just need to know that that exception type got hit. So that's what I did. I input a variable here so that I don't create something I'm not going to use. But it still will catch based upon this type of exception. So now if we run this code, it says you forgot to finish your code. If I were to do the bad thing and just comment this out, it says, oh, you finished all your code, but now you can't be calling this method, the simple method, because there's a problem. So let's leave this like it is for now for the different method. For the complex method, we're actually going to bring in a value. And we're going to have an if statement here. If name to lower equals Tim. Throw new exception. Let's pick a fun one. Insufficient memory exception. Because Tim is just that big. Equals console.readline. And then we'll pass name into that method. Now, different methods still going to throw an exception. You forgot to finish your code. Notice nothing else happens. And if I hit enter here, it goes away. Because in this try catch block, the first line had an exception. So it does not do anything below it. All these lines get skipped. And it comes down here and says, which one of these works for me? Which one of these fits my exception? In this case, this one in the middle. So it does that catch, and then it closes out the application after you hit the enter key. So if you have an exception in a try catch block, you're done in that block. So we got to fix this problem first. So let's just put a console write line here. It says, this is the different method working properly. And now we can get rid of this throw new not implemented exception. Now if we run this, it says this is a different method working properly. What is your name? Well, my name is Tim. Tim is too tall for this method. So it threw an exception. it threw the insufficient memory exception, and it bounced up here to our catch block, went all the way down to exception, and printed out the exception. Now let's make this a little bit better and say, you know what, I want to print out the EX dot and let's actually grab the entire EX, okay, the whole thing, and we're going to comment out just the message. So it'll be just the entire exception. Now we have everything. So Tim is my name. It says insufficient memory exception. Tim is too tall for this method. And there is our stack trace. All right, cool. So now let's run this again. And this time we're going to say that my name is Bob. It's an argument exception. This person isn't Tim. And there's the stack trace. Okay, so we can throw different exceptions. We can catch different exceptions in different ways. And we can even look at other options as well. Is because name is inside this try block, and it might not be defined because the exception might occur up here. But if we say string, if I can type it right, string name, and that's it. Just start it off. Maybe you can start off with an empty string. I like initialize my values so I know what the value is going to be to start. And then just use that variable in here. Now we can actually use it down here in the catch block. To lower equals Tim. Okay, so what's going to happen here? Well, as we come down through, it says, okay, exception EX, which means basically all exceptions. And it's going to say, whoa, 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 not really. Yes, all exceptions, but when means you also have to have this be true. So any exception where the name variable to lower has a value of Tim. All right, so that would be how I handle that. Now, you can put this when clause and any evaluation you want on any of these. It doesn't have to be just the exception. But that's how you can dial it in even more granularly. All right, so now we have two different exceptions. So if I run this and I say Bob, I get this person isn't Tim, like before. But if I say Tim, In your catch block, well, if it's a data access or network error or something like that, you can have a retry. Or you can have a, well, then fall back and use this database instead. That's an option or a possibility where you might use a specific catch block. Now remember, on the console right, let's zoom in on this. Oops, I gotta zoom in with this one. See, it says exceptions, and it tells me which type of exceptions come back from this particular method. So if we want to be specific about what exceptions to catch, we only need to catch the system.io.io exception. All right, we don't need to catch every exception possible. We don't need to have a not implemented exception and an invalid operation exception. Console write will only throw an IO exception. Okay, so there's some value there in knowing which exceptions might get thrown. The final thing I want to show you is called finally. So down here at the bottom, I can say finally. No parameters, no variable. But what finally does is it says, I don't care if you worked all the way through or if you threw an exception. Either way, we're going to run some code at the end. Now, why would you do this? The reason you would do this is if you had to do some cleanup work. Cleanup work that always had to happen, no matter what. So maybe in your try block, you are trying to connect to a database and you do some work. But if you're halfway through and you crash, that connection's still open. Well, the finally will close it out. Okay, that's where you put your closeout code right there. If you're working with images and you open an image and read the stream in, well, that can be a memory hog if you don't close it out properly. You put the closeout code in the finally block. So no matter what happens, whether it succeeds or fails, you're still running the finally code. Let's run this. My name is Tim. I always run. Now let's go back over here and we're going to comment out everything but the different method. Remember, the different method actually works. So it says, this is the different method working properly, and I always run. And that's it. Code, you have the ability to create exceptions and then catch exceptions and process different exceptions different ways. You can also filter down even further based upon the state of your application, whether it's a variable or whether it is, where you are in the process of something. Maybe you're trying to connect to a database and you've downloaded all the stuff, but then it crashed. Well, then you just say, you know what? Don't worry about it. Keep going. Or if you're halfway through, you could do a resume. All these different types of things you could do based upon the state of your application. But at the end of the day, you'd want to catch the basic one at least. Otherwise, if you don't catch a matching one, it's going to fall through and say, oops, You didn't catch it, therefore it's an unhandled exception. The only time you want to do that is if you're passing it up the chain. Now, no matter what, if you have a finally block, which you don't have to have, but if you have a finally block, that code is always getting run, no matter what. Okay, so that's the advanced exceptions. Let's look at our pro tip for today. Exceptions indicate unexpected behavior. So create them yourself if it makes sense. So if your application is working unexpectedly and you detect it, but you don't have access to stop it, meaning you're too far down the chain and there's got to be some stuff up the levels that has to do stuff, go ahead and create your own exception and say, there is a problem here, and let it bubble up the chain until someone who has the authority can do something about it. Usually that means a user interface layer that at least tells the user there's a problem. Okay? So don't feel bad about creating exceptions when they make sense. All right, your homework is to create a console application that throws an exception in a method that you then catch in the main method. All right? And try out those different types of exceptions. Catching different type of exceptions, throwing different type of exceptions, and make sure you understand the multiple catch blocks and the finally. All right, once you do that, come on back for the next lesson.